Keeper 1.2 trigonometric power integrals. All right, so remember for your trig integrals, you need to know some of your identities. Obviously, I want you to know all of your identities, but the most important ones for this lesson is your Pythagorean identity, your double angle identity, and for sine squared, and then your double angle identity for cosine squared. And if you know those identities, then you should be good to go. All right, so example 1, we want to integrate the integral of cosine squared theta d theta. The first thing I'm going to do is I'm going to change this over using my identity. So I'm going to change it to 1/2 plus 1/2 cosine 2 theta d theta. And then I'm going to pull the 1/2 out just to make my integration a little bit easier. All right, so now that I have the 1/2 pulled out, basically what I'm going to do is I'm going to integrate each part. So the integral of 1 is theta, and the integral of cosine 2 theta is 1/2 sine 2 theta. And then, of course, because we integrated, we like to add that plus c to the end. All right, so you can leave your answer like this, or you can go ahead and clean it up one more time by distributing that 1/2 back in. And so you'd get 1/2 theta plus 1/4 sine 2 theta plus c. Example 2, we have the integral of sine cubed beta times cosine squared beta d beta. So remember, when you have different functions, you kind of want to work with the one that's odd, and you want to set one of those aside. So instead of having sine cubed theta, I'd write that as sine beta times sine squared beta, and then I would leave the cosine squared beta alone. All right, so once I do that, that sine beta that I pulled out and I left aside, that's actually going to be my du when I do my u sub. So that means if sine is my du, then I want all my u's to be cosine. So that sine squared beta I need to change to cosine. So I'm going to have sine beta times 1 minus cosine squared beta times cosine squared beta d beta. And I did that using Pythagorean identity. All right, so now doing a simple u sub. I'm going to have u equals cosine beta. And then, so that means du is negative sine beta d beta. All right, so plugging my u's in or doing my u substitution, I'm going to end up with negative integral 1 minus u squared times u squared du. I'm going to distribute that u squared in, and then I'm going to integrate to end up with u to the 5th over 5 minus u cubed over 3 plus c. And again, I did that, I kind of switched my terms around so that I had my positive term first once I distributed in my negative. All right, now remember, we didn't start with u's, we started with betas, so we want to go ahead and substitute the u back out of the equation. So I'm going to have cosine to the 5th beta over 5 minus cosine cubed beta over 3 plus c. Example 3, we want to integrate sine to the 7x dx from 0 to pi over 2. All right, so again, because it's odd, I'm going to separate one of those out. So I have sine x times sine to the 6x dx. I'm going to change the sine to the 6 using Pythagorean identity, and I have to do it 3 times. Because remember, your Pythagorean identity is squared. Then I'm going to do a simple u sub. So u is sine, or u is cosine x. So du is negative sine x, or negative du is sine x dx. And then substituting that in, I get the integral of 1 minus u squared, 1 minus u squared, 1 minus u squared du. All right, so for me, I just found it easier to go ahead and just distribute that all the way out. So I have negative u to the 6th plus 3u to the 4th minus 3u squared plus 1 du. And then I can integrate and distribute my negative back in to get u to the 7 over 7 minus 3u to the 5th over 5 plus u cubed minus u from 0 to 1. Now notice I changed my bounds of integration, and I changed it in terms of u so that I don't have to go back and substitute back in. So remember, to change those bounds, all you have to do is plug in the original bounds into your equation for u. All right, so now that my bounds are changed, I can go ahead and work my integral out, plugging in my values, and I'm left with negative 1/7 plus 3/5 minus 1 plus 1, or 16/35.